Welcome, everybody. I'm Erwan Gatajiva, Solution Architect for Matillion. And today, the session is Give Your Data a Workout. In this session, you're going to learn how to use an ELT approach to maximize your data integration performance, extracting data from multiple sources, load it into your data warehouse, conduct complex transformations directly on the warehouse itself before connecting Tableau for more analytics and visualizations. We're going to use a fun data set to represent the data you might be working with every day. I'll walk you through an ELT-driven approach to get more out of your data. I hope each of you come away today with at least 2 new ideas you can apply within your business. We'll be using workout activity collected using Strava, a social fitness platform, supplemented with historical weather data collected from worldweatheronline.com. You'll see how to use Matillion ETL to load and transform that data on Snowflake Cloud Data Warehouse before analyzing that data in Tableau to generate the visual insights your business needs. And you'll probably learn a little bit about myself along the way because we're going to be using my own Strava data. So yes, I said ELT and not ETL. Our product is called Matillion ETL, and it's called that because when people are looking for products such as ours, they're typically looking for an ETL tool. But we do subscribe to an ELT architecture. So on the left, you might recognize this workflow, where that's your traditional ETL workflow. You're going to extract data from source systems. You're going to then pipe them through your integration layer, where you're going to apply transformations and push that out to your data warehouse. And then you may need to get more data from another source system, and you're going to pipe it through your integration layer. You might need to pull some data back from your data warehouse to join them again in your integration layer before pushing back to your data warehouse. With Matillion, we subscribe to the ELT architecture, where you're going to extract your data from your source systems, but what you're going to do is load them directly into your cloud data warehouse. And your data does not need to leave from there. With Matillion, you can build transformation logic with your data there. What you're going to do is maximize your investment on your cloud data warehouse platform, something you've already invested in. And with the cloud data warehouses that we work with, they're all massively parallel. So you're going to be able to take advantage of all of that processing power and therefore simplify your data architecture and not require as much resources for your integration layer. So in this exercise, first we connected to Strava using their APIs, and we fetched workout activities. All of that is in JSON data, looks something like this, right? Then we connected to worldweatheronline.com. Again, they have an API layer, and we needed to fetch historical hourly weather data so that we can marry that up to the activity data. That also was in JSON format, okay? So in order to, once we've loaded all that data, to prepare it, we need to do some data transformations before we can then push it to Tableau for a little more analytics and visualization. Leveraging Matillion, ETL, and Snowflake, that made this really simple, okay? So from here, what I'm going to do is I'm going to switch over and just walk you through how we did this in Matillion. Oh, technical glitch. Apologies, give me 1 minute. This was working a minute ago. I don't know, this was working a minute ago, as you saw. Yeah. Well, that's right. I've got a backup. I can share some slides that have what I need. Okay. So what we're going to do, I will adapt. So let me get over to my slides. Okay. So took some screenshots just in case there were any technical difficulties, such as this. So what you're seeing here is Matillion, okay? This is our UI. And this is showing the job that I built. Now, the thing about Matillion is you've got a couple areas. On the top left is your Project Explorer. That's where you're going to build jobs. And related to the ELT architecture, you can build two different types of jobs. Orchestration jobs that perform that EL function, extract and load into Snowflake in this case. And then you can build transformation jobs. What the transformation job will do is generate native, in this case, Snowflake SQL syntax to apply your data transformations. What you're seeing here is an orchestration job that shows how we moved data out of Strava into Snowflake. So what you're seeing here is I focused on our first step, which was to drop and recreate a table where we wanted to land all of my activity data, all of my workout data. And you can kind of see here the structure. Now, one of the big call-outs here is we're going to leverage Snowflake's variant data type. So a variant data type is a really powerful data type that Snowflake allows for you to define. What that allows for you to do is store JSON data or array type data into a string-like data type, but when it's in that variant data type, you can use Snowflake functions to parse that JSON data. So within Strava and activity data, every activity will have 0 or more segments, where a segment represents going from point A to point B. And so when I get all of my details about my activities, I will get all of those segments in nested JSON arrays. And so what I did was when I fetched that, I stuffed that into that variant data type. Moving on, what I did was after I prepped that table that was meant for all of my activity details, I'd set up an API profile and simply used our API query component. With that API query component, I was able to hook it into Strava's API, and I said, give me all of my activities for me being the athlete. And I was able to fetch all of these fields. This is just a representation of some of the fields. I had to pass in an API token. So that API token I got going into Strava's side, and I was able, as my own user, say, give me my token. So I've designed this job in a way where it would be scalable to, let's say, a team of athletes, if necessary. So this call is simply going to go through and get all of the activities for this athlete that's represented by an API token. Some of the nuances to Strava's API was that it would return data in pages. So there would be 30 activities per page, and you had to go through all of them. Matillion makes it really easy to deal with all of that. Just by executing that one component, I was able to fetch all of my activities. Oh, okay, yeah. So the next step was after I got all of my activities, I needed to get more details about my activities. So every Strava API, or every Strava activity would have an ID that represented that activity ID. And I could pass that ID, and what I did was I go into my table that has all of my workout activities, each represented by an activity ID, and I can iterate through them. And by iterating, sorry. So by iterating through every row of my activities, I called another endpoint at Strava to get all of the details for those activities. And in those details had those segment efforts, for instance. From there, I needed to do some data cleansing. So what you're seeing here is the next part of my workflow. All of these boxes, these components, represent transformation jobs that I had built. So I've got all of my Strava data and the activities and the details in Snowflake. Now I needed to do a little data transformation for a couple of different reasons. One, I want to get my weather data from World Weather Online. Now that API requires 3 inputs: a latitude, longitude, a start date, and an end date. But they also have a limit on being able to return data for 30 days at a time. So I'd have to make multiple API calls to World Weather Online. So with all of that known, I structured my data from Strava where I have a latitude and longitude and a date of when my activity occurred. And so what I needed to do in this first step was to organize all of that data in a way that's going to make it easy to fetch data from World Weather Online. So here, what I've done is this is an example of my activity details that's been stored in the segment efforts in my variant data type. So this would be an example of leveraging Snowflake's lateral flatten function to then take that JSON data and actually just flatten it out, make it very simple. And I put that into another table that has 1 row per segment. So I have an activity table where it's 1 row per activity and a segment detail table that's going to have 0 or more segments for every activity. And all of that was flattened out by doing this. Now, going into what I was describing about how I had to organize my data, this is an inside look at that transformation job. So what I did was I pulled all of my activities out of my main table, 1 row per activity. And what I needed to do, as you can see here, is I needed to do some transformations. And so here I'm using a calculator component. And what that does is it exposes all of Snowflake's inbuilt functions to do data transformations. And so here I'm simply saying, hey, I need to get my year and month from my start date. Now, the other things that I had to do is I'm using an aggregate to say what's my min and max start date for a latitude, longitude, and year and month. What that allowed me to do was to make sure that I would not have a date range that exceeded 30 days, okay? Because knowing my World Weather Online business requirement was that I could only fetch 30 days worth of data at a time. So this was essentially doing all of that data transformation, preparing my data. At the end of the day, I just created a view that represented my transformed data. And so another thing that I needed to do was when I started to work in Tableau, I wanted to take that latitude and longitude, but be able to visualize it with named locations. In the Strava detail data, there were named locations, country, state, city, at the segment level, but it was not always populated. And as I mentioned earlier, every activity could have 0 or more segments, okay? So when I had it, I was able to filter out any of my segments that did include my location stuff. So filtering anything that didn't have any sort of location information, I got rid of that. Then, because I can have 0 or more segments, I chose my first location, and I updated my main activity table with that location information. Now, I mentioned there I still had some activities where I still didn't have location information. So I built another small job that would leverage, here, that's what this job is doing. We have a Python scripting component. So if there's ever some little bit of Python code that you need to inject, that's what I did here. So what I did was I used a Python library that would accept a latitude and longitude as inputs and give me back my country, state, and city. And so that's what I'm doing here for any remaining activities that didn't have location information. And I went ahead and put that back into my activity data. And so here, the last thing I needed to do, and I could have done this in Tableau, but I had some states. Most of them were the full name of a state, but in some instances, it was just like a 2-letter abbreviation. And so I wanted to standardize, clean that up. I could have done it in Tableau. Here, I just built a simple transformation job, did it all in Snowflake. One of the benefits of that is that while I did my visualization in Tableau, there might be some other reporting system that might want to access that data. So it's nice to do it directly in the data warehouse so that anything that accesses it gets that same standardized data. So from here, I'm now showing you my next orchestration job, which is, again, pulling data from World Weather Online. So this is the entire job. Looking a little closer on the left, similar to earlier, I've defined an API profile where I'm going to get all these types of fields, okay? So it's like, I've got everything from weather conditions and humidity and min-max, and it's all at the hourly level, okay? And so what I did was I passed in information here, so you can see it, the latitude and longitude, you're using variables, okay? But these are being passed into this job. So I'm getting my latitude, longitude, my start date and end date, and get me all of those hourly weather conditions, and that's never going to be more than a 30-day range, okay? And so what I've done is iterated through all of my prepared data that I put into that view to get all of my hourly data. And so now that once I get that hourly data, I saved it off in another transformation job, and then I also then joined it with my Strava activity data and married those up together. That's what those two transformation jobs are doing. So this is an example of my transformation job where I got my activity data. These are all my Strava activities, and now I'm bumping it up against my World Weather Online weather data. We're joining the two. So we're joining based upon latitude and longitude, as well as I had to do a little transformation because in the World Weather Online hourly data, there was a date and an hour, but that hour was represented as 100, 200, 300. So I had to take my actual activity, which has a start date timestamp, and I had to parse out the hour, multiply that by 100, and that's how I'm able to join against the two data sets. And from there, I'm going to bump up against a table that I've got to load all of my cross-references, my activities, what are the weather conditions during that. And so here I could say, have I loaded that before? Am I trying to reload an activity I've already derived? And so that's where my detect changes component comes in, which is a really cool component. It allows you to join two data sets that will then tell you with your two flows, it'll add a indicator field. And it'll tell you this row contains, it's a new row of data, it's a changed row of data, it's identical to the two you're comparing, deleted. And so what I can simply do is then say, I added a filter that says, only deal with my new data. So that detect changes component is really nice, especially if, let's say, you're doing a slowly changing dimension type workflow in your job design. So that detect changes is great, because you can say, well, new rows, insert into my dimension table, updated rows, insert and deactivate my old row, something along those lines. So you can add a lot of logic around that indicator flag that is going to be added. So going back into it, this is showing some of the data that I've now then took and visualized in Tableau. So now you're going to learn a little bit something about myself. So I have activity data from about 5 years, 2013 to current. In that time, I moved across country a couple of times, and I tried to be pretty healthy and try to run. So what you're seeing is that did a lot of stuff in Colorado, I did a lot of stuff in Virginia, and then all the smaller dots would be like I'm traveling for work or on vacation, getting a workout in here and there. And what you can actually see is that all of these activities, and so the size of the circle is going to show you how many in that area, what the weather was like during that. So you can see, like in Colorado, sunny Colorado, there's just a lot of sunny days there, and that's what you're actually seeing here. Another really cool visualization is, this also shows a little bit about, again, myself, but my activity data starts back in 2013, 2014. You can see I lived in Colorado at the time. My elevation runs were over 5,000 feet. What you're also seeing with the coloring was the distance I would run. So I just started running then, So I wasn't running very much, okay? And then my line here is showing my average pace, my mile pace, okay? And so what is really interesting, at least for me to see, was that I started running and I was kind of inconsistent and not very, not going very large distances. My pace was erratic. I took a big break, and when I took that big break, my pace went up. I moved across the country to Virginia, where I'm now down closer to sea level. And again, my pace was kind of high, but as I stuck with it and my distances went up, my average pace went down. I moved back to Colorado, right around beginning of this year, and I'm even higher up in the mountains now, okay? So now I'm running at 7,000 feet, and you can see my first workout there, not so nice, it hurt, okay? But I've been sticking with it, my distance has been going up, and my times have been coming down. Oh. Just another way to look at the data. So what I did here in Tableau is, if you guys are familiar with the Sankey diagram, kind of a fun way to visualize data. I wish my laptop were working because it's all interactive and everything. But what you can see here is what you kind of saw in the first map was that, hey, I did most of my workouts in Virginia and Colorado. What you can also see is that the Sankey diagram allows me to connect two dimensions with some metrics, right? And so the thickness of the line between the two is showing basically the number of workouts in that location with that weather condition. So you can kind of see that if it's sunny out, I'm going to be out there. But what you can't see, and you'd see if I hovered over it, I had 1% on rainy days. So I'm kind of a fair weather athlete, as you would imagine. So I'm going to slide back a few slides. Okay, so I just went over kind of very quickly, my end-to-end process. Would love to, if anybody wants to see it live, because I had these problems, we've got a booth right over there. Matillion, we build products for 3 popular cloud data warehouse platforms: Redshift, BigQuery, and Snowflake. Each one of our products look and feel exactly the same. The UI is the same. You're going to find some components that are specific to each cloud data warehouse platform for certain functionality that only exists there. So, and what we will always do for all of our products will generate native code for that cloud data warehouse platform. So, if you want to learn more, go to matillion.com. We're on all of your popular marketplaces, and you can go on there and spin up a free trial of Matillion. You can do a 14-day free trial, use Matillion against your own data, and spin it up against Redshift or BigQuery, Snowflake. Great way to test out the product. We deliver it all on the cloud marketplaces that you are on. So what's going to happen is you'll get a virtual machine running in your own cloud environment, running Matillion. There will be no data that ever passes through a Matillion server that a Matillion employee will ever have access to, because it's in your own environment and your security is something that you control. So I know there were a couple technical difficulties today, but hopefully you still found some value in the session. I'd be happy to show you guys a little bit more detail, give you a proper demo of Matillion. Hopefully you could come away today with at least 1 or 2 learnings and things and ideas that you might be able to apply within your own business environment. With, again, just using some sample data that I thought was fun to help demonstrate some techniques that you could use in your day-to-day jobs. So that's it. Time for some questions if anybody wants it. Sure. Mm-hmm. Okay, so the question is, we have product for 3 different cloud data warehouses: Redshift, Snowflake, BigQuery. And so your question really is, how different are the products? Okay, so what you saw in the UI, it's going to be the same across the board. Yeah. So there are a couple components, like for Snowflake as an example, there's a component that we provide, it's called Alter Warehouse. Snowflake allows you to separate compute and storage. And that alter warehouse allows you to size up and down your warehouse. So we provide a component that would allow you to do that within your Matillion job. That component's not going to exist in our Redshift product, right? Yeah. Yeah, and and I mentioned earlier that calculator function that I use in a component in the transformation job, those expose all of your native functions in your cloud data warehouse platform. So the functions that are available there are going to be different in the Redshift version versus the Snowflake, but it's still a calculator component, and it'll behave and look the same. Yeah. Go ahead. All right, yeah, so the question is, do you own your Matillion instance? And so what happens is, let's just say you spin up a Matillion instance on the AWS marketplace. What's actually gonna happen is you'll spin up an EC2 instance through that launching. It's gonna live in your AWS account in your VPC. It'll be running an AMI, an Amazon Machine Image, that represents the entire Matillion product, but it's owned by you. Yeah, well, that's the ELT. So yeah, the question is there's any caching or storage of data on the Matillion instance. We do have a local data store on there. It's a Mongo database. It stores all of your metadata. So the job code, all the task history, users that you set up, all the things that make Matillion operate, but any of your actual data that's passing through it will not, it's never at rest there. It just streams it through because of that ELT architecture basically says, and what we're going to do, and I didn't mention this, we abide by best practice, which is if you're going to extract data and load it into any of these data warehouses, you don't typically want to insert data directly rows at a time. What you want to do is stage it into an area before doing a bulk copy into. And Matillion does that for all of our extract and load components. You'll specify in that component configuration what's your target table and what's your staging area. So for our Snowflake product, you can specify an S3 bucket to stage, but you can also use a Snowflake internal stage. Whereas our Redshift product, you just have an S3 bucket that you can choose. But that's the idea, is it will stream the data through Matillion, stage it into a flat file out into a staging area. When we're done streaming, we'll then issue a copy command to copy that into your data warehouse, and then clean up that file afterwards. So, yeah, so we do scheduling. There's a built-in, it's a quartz-based scheduler. We have some techniques around event-driven execution as well. Yeah. Yeah, so we have some techniques around dealing with errors. What you'll see in all of our orchestration jobs, every component has nubs, output nubs. Green's on success, red is on failure. And you can say on failure, maybe publish a message to SNS, simple notification service. So people can get notified that way. So we're not gonna reinvent the wheel. You're already in the cloud on AWS. We'll use those services to do things like email notifications, text message notifications. We'll use SQS, which you can deal with it more programmatically. The SQS is part of that event-driven model where we can listen to an SQS queue, and you put a message of a specific format into that queue that we're listening to, and as a result, what we'll do is kick off a job based upon that happening. So, yeah. It is. So ETL versus ELT is not new. It's actually kind of almost a religious debate amongst integration developers. It's never been very cost effective because typically in your old paradigm with your Netezza appliances and things, your storage and compute is very expensive. But now with cloud data warehouses, that price point is much lower, and we can take advantage of that MPP nature, and it's not going to cost you an arm and a leg like it would have in prior years. Yeah, yeah, exactly. All right. Well, thanks, guys. Appreciate it.
Good working through the tech. I've never similarly been passing that background. So
Thanks. Yeah.
the cost?
Oh, it's hourly. You'll find it in the marketplace, but it can be as little as like $1.40 an hour, I want to say. Yeah. Yeah. Yeah.
All right, thank you.
Yeah. Hey, thank you.
I'm
Oh, thank you. I appreciate it. Yeah, I know. We did everything right, and then you go to do it, and Murphy's Law.
Yeah, I
So.
was on my phone, like looking at Lavono, like chat
Yeah.
rooms. I'm like, what the heck is going on?
Yeah.
They're talking about resetting all this, updating scripts. I don't know.
Yeah, that was a tough one.